Last night, you lived an entire experience. You didn't choose, didn't plan, and can barely remember. There were people in it, emotions, maybe fear, maybe something beautiful. And your brain built all of it from nothing while you were completely unconscious. Scientists have spent over a century trying to understand why that happens, and what they found is genuinely surprising. Dreams aren't random noise. They're doing something specific, something your waking mind can't do on its own. By the end of this video, you'll know exactly what that is. Here's the first myth to clear up. Sleep is not rest for your brain. When your body shuts down for the night, your brain shifts into a completely different mode of operation. And during one specific stage of sleep, it becomes more electrically active than when you're sitting awake doing nothing. That stage is called REM sleep, rapid eye movement. It was discovered in 1953, entirely by accident. A researcher at the University of Chicago named Eugene A. Surinsky noticed his sleeping son's eyes flickering rapidly beneath his eyelids. He connected him to a brainwave monitor, expecting flat, quiet activity. What he got instead looked almost identical to a waking brain. When people were woken during this stage, nearly all of them reported the same thing. They'd been dreaming vividly. We now know you enter REM sleep 4 to 6 times every night. By the time your alarm goes off, you've spent nearly 2 hours inside a world your brain invented completely on its own. So the real question isn't whether you dream, it's why your brain does this at all. Here's the leading scientific answer, and it's more practical than you'd expect. Every day, your brain absorbs an enormous amount of information. Conversations, emotions, new skills, problems you haven't solved yet. It can't process all of that while you're awake. There simply isn't enough bandwidth. So at night, while you sleep, your brain goes to work. It sorts through what happened, decides what matters, strengthens useful memories, and quietly discards the rest. This process is called memory consolidation, and it's one of the most well-supported ideas in modern neuroscience. The proof is striking. In a landmark study, 2 groups of people were taught a complex task. One group slept afterward, the other stayed awake. When both groups were tested again, the people who slept performed significantly better. Not because they practiced more, but because their sleeping brains had reinforced the neural pathways for that skill overnight. You can actually get better at something while you sleep. That part is proven. Now, where do dreams fit in? Many neuroscientists believe that dreams are the experience of memory consolidation as it happens. Your brain is replaying, comparing, and cross-referencing the events of your day, and you're watching from the inside. That's why dreams feel like scrambled versions of real life. Your brain isn't being random, it's making connections. And sometimes, the connections it makes are extraordinary. In 1865, a German chemist named August Kekule had been stuck for years on the same problem, the molecular structure of benzene. He knew what atoms the molecule contained. He couldn't figure out how they were arranged. One night, he fell asleep and dreamed of a snake biting its own tail, spinning in a circle. When he woke up, the answer was immediate. The benzene molecule was a ring, a closed loop, not a chain. He was right. That single dream-born insight unlocked a branch of chemistry that still shapes science today. Kekule isn't alone. Paul McCartney said the melody to Yesterday, one of the most recorded songs in history, came to him fully formed in a dream. He woke up, went straight to the piano, and played it out. This isn't coincidence. There's a biological reason it happens. When you're awake, the rational part of your brain, the prefrontal cortex, acts as a filter. It suppresses ideas that seem illogical. It keeps your thinking linear and controlled. During REM sleep, that filter is turned way down. Your brain makes associations it would never allow while you're conscious. It's less disciplined. And sometimes, that's exactly what's needed. Scientists call this relational memory processing, the ability to connect things that don't obviously belong together. Dreams might be the most creative state your brain ever reaches. Not every dream is a creative breakthrough. Some are terrifying. Nightmares are universal. Every culture across human history has experienced them. And for most of that history, people assumed they meant something supernatural. Visits from spirits, signs of illness. The scientific explanation is less dramatic, but more interesting. Nightmares spike during periods of stress, grief, anxiety, and trauma. People with PTSD often experience nightmares that replay traumatic memories with disturbing accuracy. This isn't random. It points to something your brain is actively trying to do. Neuroscientist Matthew Walker, one of the leading researchers on sleep, has proposed that REM sleep acts as a form of overnight emotional therapy. Your brain revisits emotionally charged memories, but in a neurochemical environment that's different from waking. Specifically, a stress chemical called norepinephrine is suppressed during REM sleep. The idea is that your brain replays difficult experiences while the emotional charge is dialed down, so the memory can be processed without the full weight of the original pain. Evidence supports this. People who are repeatedly woken during REM sleep show higher emotional reactivity the next day. They overreact to minor stressors. They struggle to regulate their feelings. Your nightmares, as unpleasant as they are, may be your brain's attempt to help you survive your own experiences. And here's something most people don't know. Nightmares can actually be changed. A clinical technique called image rehearsal therapy teaches people to consciously rewrite their nightmare endings while awake, rehearsing the new version in their mind, repeatedly. Over time, the dream itself changes. It's one of the most effective treatments for nightmare disorder and PTSD-related dreams. Your sleeping brain is not entirely beyond your control. So we have memory consolidation, emotional processing, creative problem solving. That's a lot of good science, but none of it answers the deepest question about dreaming. Why does it feel like something? When you're dreaming, a completely fabricated world feels absolutely real. You feel love. You feel fear. Your heart actually races. Some people wake up with real tears on their face from something that never happened. Your brain is generating an entire reality from electrochemical signals alone. No external input, no actual people, no real danger. And yet, it's convincing enough to make you cry. This sits at the center of what philosophers and scientists call the hard problem of consciousness, the question of how physical processes in the brain produce a subjective experience. How does matter feel like something from the inside? We don't have an answer, not yet. Some researchers believe that understanding dreams will be one of the keys to unlocking it. Because if a brain can build a completely believable reality every single night, with sensations, emotions, and meaning, then understanding how that happens might tell us something profound about how consciousness works at all. Dreams have followed us through all of human history. Ancient civilizations carved their dreams into stone. Philosophers debated what they meant. Freud believed they were coded messages from the unconscious. Modern neuroscience believes they're memory, emotion, and creativity, running simultaneously in a mind that never fully rests. And maybe none of those views are entirely wrong. What we know for certain is this. Every night, while you're unaware, your brain is doing some of its most important work. It's strengthening who you are, processing what you've been through, and occasionally making connections that your waking mind never would. You'll dream again tonight. Most of it won't survive until morning. But here's what stays with me. If your brain can build a world convincing enough to make you feel real fear, real joy, real grief, from nothing but electricity, what exactly is the difference between that world and this one? If you're curious about how your mind and our world actually works, subscribe to Why Decoded, because everything has a reason.